everyone. So today's problem of the day is jump game 5. What is given in description? Given an array of integers ARR and an integer D. In one step, you can jump from index I to index I plus X, where I plus X should be less than the array length, and X can range from 0 till less than equals to D. And we can either jump to I minus X, where I minus X should be greater than equals to 0, and X live from should be greater than equals to 0 and less than equals to D. In addition, you can only jump from index I to index J if that value at index I should be greater than index J, and any value lying between index I and J should have the lesser value than that value at index I. You can choose any index of the array and start jumping. Return the maximum number of indices you can visit. Notice that you cannot jump outside of the array at any time. So this is basically an easy question only. Where if you will see this with this example for better clarity, we will be giving some array ARR, and we will be giving D integer. What is given? What we need to find in this question? Like if we will be starting from any index, then what will be the maximum number of indexes that we can visit? And from if I am starting suppose from this index, then I can move to any indices where the value at that index should be less than equals to value at this index, and that will be at a distance of 2 or less than 2. So if I will see in this example, if I am starting from this index 10, this 10th index, then this value is 12. So from 12, which index I can jump? Since this is the value at this is 6 and it is lesser than this 12, so we can jump to this. 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 But we can't jump to this because this value at this index is greater than 12 and the distance is also greater than 12. We can jump to this 9 or 8 only because we need to. We can jump to maximum two distance only. We can jump. So we can either jump to this or I can either jump to this. Suppose I have jumped from this index to this index. Then from this index, which all indices we can either jump to this index, black one, or either we can jump to this or this. Because maximum 2 index we need to jump and the value should be less than equals to 10, and the 7, 9 and 6 are less than 10. So we can jump to these 3. Now if you will see, if we are moving to the 10th index, then after this suppose we move to this index. Then from 9th index, what all indexes we can jump? We can't jump to this 8. Why we can't jump to this 8? Because it is at distance 2 also, and value is 8 also, which is less than 9, but we can't jump to this index because the every value, if suppose I am jumping from this index to this index, so in between all the indexes should have lesser value than this the current index. Okay? That's what written in the question. Like the index we are jumping also should have less value than the current index, and all the middle value also should have less value than the current index. So we can't jump to this. So from this 9 we can jump to only this. This 10 also value is greater, so we can't jump to this 10, so we can jump to this 12. So what is the one possible solution? One possible solution is like 12, 10, 9 and 7. The maximum indexes we are covering is 4, so we can. So its answer is 4. If you will see, if we will consider some other scenario, like I'm starting suppose from this index. So from this index I can jump to this or this index. Suppose I have jumped to this index. And then from this index I can jump to this index. But from this index there are no other indices I can jump. I am blocked. This I can't jump because this value is greater than this current value. This value is smaller, but this middle value is greater, so I can't jump to this. So a maximum I can jump in this case will be 3, which is less than this, the first one we tried. If we will try for the next one, something like I am starting from this 13. From 13, I can jump to this 8, then 6. In this case also, I will be covering only 3 indices. The maximum indices possible till now will be 4. So our answer is 4. So what will be the solution? How we can write the solution? Solution will be like we need to try for every indexes, like from starting from every indices, like if I'm starting from this, how many elements I can cover. Starting from this index, how many element I can cover. Starting from this index, how many element. In that way, I need to cover all the indices. For every indices, we need to loop it, and for every indices, we will try key which suppose I'm at this index, so which what all indices I can jump. So basically the same thing I have done in my solution. If you will see, like because the number of element in the constraint, it is given like it is greater than 1, greater than equals to 1. So I have initialized my answer as 1, because if we will be starting from any indices, then that index will automatically will be counted. So I'm initializing it with 1. And what I'm doing, I'm covering all the element. I like in this for loop is basically doing key if it is like starting from ith index, how many indexes we can cover, and this I will be starting from 0 till n minus 1. Suppose we are starting from 0th index, so the psi value will be 0. Then this answer equals to maximum of answer, comma what value we can get from this function. This function will return the number of indices that we can cover from this ith index, and at the end we can return answer. So what we can do in this function is like from ith index we started, and initially the answer is equals to 1, because we are currently at one index, so that index is automatically covered. Then if we will try for the left, so left mein j equals to I minus 1. Left side we will be starting from I minus 1, and j should be greater than equals to 0 comma I minus d, because d distance we need to cover, but the index should be greater than equals to 0. So maximum of 0 comma I minus d and j minus minus. If any index is having the value greater than equals to the current index, then we can break the solution. Otherwise, we will be answer equals to maximum of answer comma 1 plus, and we will be adding the jth index, and we will be using recursion to find the value from the jth index. The same thing we will be doing for the right. J start from I plus 1 till j less than equals to minimum of I plus d, because we need to cover, we can jump to d distance, and n minus 1. The index should be less than equals to n minus 1. If it that index value should be that value at that index is greater than equals to our current element, then we can break the solution. Otherwise, we will be doing 1 plus, we will be doing recursion for that next index, and at the end we can return answer. So, but in this case, if you will see the time complexity, since we are using this one for loop, the big of n into this is some exponential will be their time complexity, because we are using recursion in this case. But if you will see the constraint, it is given that the time should be less than equals to 10 to the power 3. That means we need to find some solution in n square or n square log n, because n cube will be 10 to the power 9, and which is greater than 10 to the power 8, and we will get TLE in this case. So we need to find some solution in n square or n square log n time complexity. This is exponential to this will be something n into d की power n something, so it will give you TLE. So what is how we can optimize it? Since you know that from any indexes, if I am starting from some indexes this, and I reach to this index, if I am starting from this index, some other index, and I am reaching this index, from this index, how many elements I am covering will be constant only. If I'm at this index, and suppose in to jump I reach to this index, then from this index maximum jump I can take will be 3. So for this index the maximum will be 5, because 2 already and 3 from here. But from if this index I'm seeing, from this to this index, if it is taking one jump, and from this index to this, it is automatically 3. For this also it will be 3, and for this also it will. So we are counting this for this index, we are counting twice. So since we are doing this repetitive, so we can use DP here. So I have used DP here. So what I have done, I have initialized multi DP, and I initialized every indices with -1. Then if at the end of the answer, if this DP of I not equals to -1, that means we have not calculated answer for ith index. Then in that case we can further solve one question. If it is not equals to -1, that means we already got the answer for ith index. Then we can simply return dp of I. Otherwise, we can do this left and right scenarios. And at the end, we will use this dp of I equals to answer, so that dp of I will be updated, so that in next time if we are reaching at ith index, then we will simply use this dp of I, and we will not be needing this left and right traversal. So in this case, if you will see the time complexity, the time complexity in this case will be n, because we are using this one for loop, and this solve function is taking d time complexity, because we are traversing only d distance. Time complexity will be this, and space complexity we have used only one factor, so space complexity will be big of n. So yeah, thank you.